This thing like gets covered.
But
Covered with stuff from the...
that's interesting, Allison. That's very interesting.
Yeah, he's not doing anything yet.
No.
So basically we're going to do momentum experiments. At the end of the unit you're going to be able to use one of these things. Okay? The most important thing about doing an experiment on the air track is to make sure it's level. The way to level an air track is I'm just holding my thumb against this and I let go of it. If it starts to roll to the right, it's screwing itself into this surface. That's probably bad. Okay? I'm like turning that thing and it's styrofoam. So it's not working so well. Here we go.
That's not level.
Just give it a surface that it won't screw itself into. Okay. So if you want to see if it's level, you hold it. Obviously it's not, so I'm turning the screw. And I'm still turning the screw. And you will find that it's not possible to level all of the track. So if you were to do an experiment that happens, say, in the middle of the track, level the middle of the track, you might find that the one end might not be level. Like that part's not level, but this part is level. Okay. Now, this is momentum. Momentum is mass times velocity. That's not all that hard to figure out. Okay. So, and momentum is a lowercase p. Right? Yes? Okay, so that line paper you used in grade school, why momentum is a p, right, is that there was originally a silent p. Right? All p's next to n's or m's are silent, right? Except for like cases like pump, where you do say it, but like pneumatic, you don't say pneumatic, right? The same reason you wouldn't say momentum, right? So there was a silent p in front of momentum, but then they dropped it. I think like King Richard III or something like that dropped the p, right? He was kind of a slimy bastard, right? But anyway. There's our formula. Really, it's just mass times velocity. So if I multiply, if I've got a 100 kilogram object and it's going 3 meters per second, its momentum is 300 kilogram meters per second. And there's no abbreviation for this, right? I used to like pick some kid in the class and I go, that's known as a Laban of momentum, right? And the kid would be like, have this brief moment of like, I'm having a better than average day. And then they would have this sort of like worse than average moment when they realized I was making fun of their name or something like that, right? Or just picking them out of the crowd randomly, right? You know? And then fully a third of the class would really believe me that there really was a unit called a Laban, and they would label things for the rest of their life with a capital L or something like that, right? You know? And I could never get it out of them that it really was.
On the IB physics test.
Yeah, Laban. Laban of momentum. Okay. So that's all it is. It's just kilogram meters per second. So that's what momentum is. Now, why is it important? Well, I will show you why. Okay? These guys are going to collide, and if they're moving the same speed, they'll always end up going the way that the heavier one was going. Isn't that right?
Yeah.
Right? That's because the heavier one has more momentum. Okay? So if I want these guys to hit and stop dead, what's got to be true? What do I have to do?
Make that one stronger.
This one has to go faster. Is it possible that if I gave them the same but opposite momentum that they would stop dead?
Yeah.
Right, so because it's got less mass, I give it more velocity, its momentum would be equal to this thing's momentum, which is more mass but less velocity, right? So let's see if I can do that. Dang. Okay, let's try it again. Okay, calculating. Poop. Okay. There, it stopped. Look. Right? You can imagine if I punched through that enough, right, I could get them to stop dead. Now, where would the energy go? Momentum, there's no problem. We had positive momentum from this guy. This guy had positive momentum because it was going to the right. This guy had negative momentum. If their momentum was equal and opposite, then they add to 0 before they collide, doesn't it?
Yeah.
Positive 10, negative 10 adds to 0, right? So there's no problem with momentum. What about energy? They both were moving to begin with. Where does the energy go? Let's try it again. I'm going to try it. I'm really going to try it. Oh, that was close. It was going a little too fast. Where does the energy go if it actually stops? No, not quite. Ooh, that was really good. Where does the energy go?
Friction? No?
Do you notice that it kind of goes like that when it hits, right? It goes, it does this like cosmic quaver, right? Okay, I'll bet it's probably like, you can also hear it hit the track, so some of the energy goes into friction on the track because it clanks a little bit, right? Okay, and it also is vibrating back and forth. I bet it just gets rid of it in the air, heats up the air a little bit, I'm guessing. Sound. When you're using these, when you use these later in the Momentum Lab, the worst thing you can do is drop one of these gliders, because what do you suppose happens if you drop it right on that corner and the corner gets a big ugly dent in it? What happens when it tries to slide?
It won't.
It touches the track, and then we've got to like file that off, and you know, there we go. Just be careful. All right. You should.